Hey guys, today we're going to go through a few different pulley problems. So our first pulley problem involves two particles P and Q. The mass of P is 3m and the mass of Q is 4m. So let's begin by depicting on the diagram all the forces that are involved in this pulley. So if the mass of P is 3m, then the weight of P is 3mg, where g is the gravitational constant. And if the mass of Q is 4m, then the weight of Q is 4mg. And we also have tension in both ends of the string pointing towards the pulley, which we abbreviate with the letter T. And the tension is equal, so this T is equal to this T in both ends of the string. Now, if the system is released from rest, then what would the motion of the two particles be? Well, we know that Q is obviously heavier than P, so Q will descend, so the acceleration of Q is going to be down. And P, therefore, has to be accelerating up at the same rate that Q is accelerating down. Let's try to determine an equation for A, the acceleration, using the equation F equals ma. If we just consider Q for the time being, the forces acting on Q, we have the weight and we have tension. And since Q is accelerating down, let's take down to be our positive direction. So we have positive 4mg, and we have negative tension opposing it. So 4mg minus T is equal to the mass times acceleration. So the mass is 4m, the acceleration is a. So this equation is describing the motion of Q. If we do the same thing for P now, let's take up to be the positive direction this time because it's accelerating up. So the positive force is going to be T, then we have negative 3mg in the opposite direction, and this is equal to the mass 3m times the acceleration a. And what we end up with is a pair of simultaneous equations in terms of T, m, and a. So if we're just interested in finding a, then we could add the two equations together, and that would eliminate T. So if we add the two equations on the left, we're going to get 4mg minus T plus T minus 3mg. So we're going to have 1mg. And then on the right hand side, we're going to have 4ma plus 3ma, which is 7ma. And then what you'll notice is that the m's are going to cancel. And so in fact, the acceleration is independent from the value of m. And so a becomes g over 7. So we have a value for a. If we plug this back into our original equations, then we can then solve for t as well. So let's use the second one. T minus 3mg is equal to 3ma. We know that a is g over 7, so t is equal to 3mg plus 3m g over 7. So we add these together, we get t. Well, we know 3mg is the same as 21 over 7. So now we're left with 21 plus 3 over 7 mg is 24 over 7 mg newtons. So the previous pulley problem was quite algebraic. This one, on the other hand, is going to be more numerical. So we have a pulley. This time it's going to be attached to a table. We have two particles P and Q. The mass of P is 5 kilograms. The mass of Q is 3 kilograms. And there is friction between P and the table. So the table is rough, and the friction has magnitude of K. And we're told the system is released from rest, and Q descends 6 meters in 2 seconds. Calculate the tension in the string and the value of K. So as always, we're going to need to depict the forces on the diagram. So we have the weight of Q, 3g. We have the weight of P, which is 5g. We have the normal reaction force between P and the table. So that's going to be 5g because the table is perfectly horizontal, and then we also have tension in the string, again pointing towards the pulley. And we're told in the question that Q descends 6 meters, so the acceleration of Q is going to be down, and the acceleration of P is going to be to the right. And again, A is the same for both P and Q. So let's try to work out the value of A using the information they've given in the question. So we've been given a displacement and a time. So let's use the Suvat equations here. Let's take down to be positive again. So the displacement of Q is 6 meters down. That's occurred in 2 seconds. And because we know that the system was released from rest, then the initial speed of Q is 0 meters per second. And so with these three variables, we're able to find the value of A. So we're going to use the Suvat equation that doesn't involve the letter V. So that equation is S equals ut plus a half AT squared. So 6 is equal to 0 plus a half A times 4. Therefore, A is equal to 6 over 2, so A is 3 meters per second squared. And now that we know the value of A, it should be very easy to work out the tension. Let's now focus on the force equations. So if we start by just thinking about Q, and we're going to use the equation F equals ma. Okay, so again, let's take down to be positive. The forces acting on Q are the weight, 3g, and tension going in the opposite direction. And the forces are equal to the mass of Q multiplied by the acceleration, which is 3. So tension is equal to 3g minus 9, which is, I believe, 20.4 newtons. Now, in order to find the value of K, we're going to need to shift our attention to the particle P. So let's do F equals ma again on the particle P. So the force is acting on P in the horizontal direction, so we're going to ignore the weight and the reaction force. They're not particularly relevant in this case. We have tension, so take right to be the positive direction. We have tension minus friction of magnitude K, and that's equal to the mass, which is 5, times the acceleration, 3. Now remember, T is the same for both Q and P, therefore we can rearrange this for K. So K is equal to 20.4 tension minus 15, which is 5.4 newtons. So for this pulley problem, we have two particles, P and Q, with masses 4 kilograms and m kilograms, and m is less than 4. So the system is released from rest, and the acceleration of each particle has magnitude g over 2. Find the tension in the string and the value of m. So we're going to start by labeling all the forces. So the weight of P is 4g, and the weight of Q is mg. We're going to have tension in both ends of the string. And because we know that m is less than 4, then P has to be accelerating down, and Q has to be, therefore, accelerating up. And since we know more information about P than we do about Q, let's consider what's happening to P first. So using F equals ma, and acceleration is down, so take down to be the positive direction. So the forces are 4g in the positive direction and T in the negative direction, and that's equal to the mass, which is 4, times the acceleration, which we're told is g over 2. So rearranging this for T, so T is equal to 4g minus 4g over 2, that's just 2g. So T is equal to 2g newtons. So having worked out the value of T, let's now consider what's happening to Q in order to work out the value of M. So again, we're going to use F equals MA on Q. So initially we did it on P, now we're going to do it on Q. So now let's take up to be the positive direction. So the force going in the positive direction is tension, and we have a weight opposing it, T minus mg, is equal to the mass, which is m, times the acceleration, which is g over 2. So we know the tension is 2g over n. So let me continue over here. So 2g minus mg is equal to mg over 2. So notice how we have g in every term of this equation, so we can cancel it like this. So we're left with 2 minus m is equal to m over 2. So if we multiply everything by 2, we get 4 minus 2m is equal to m. So 3m is equal to 4. So m is equal to 4 over 3 kilograms, which is approximately 1.3 kilograms to 2 sig fig. Hey guys, thanks for sticking around. If you got value from the video, then smash that subscribe button, and I'll see you next time.